I've got this aluminum cast part here, aluminum casting, that I'm going to scan with the newest tool in our 3D scanning arsenal, the Scantech Nimble Track. Just got it in here at the office, and we're really excited about it. So let's get to it. Get this guy out of the way. Bring this case up onto the table so I can show you what's involved in setting this guy up. This is the first all wireless metrology grade scanner on the market. So it's two main pieces of hardware. The first of which is this tracker. This guy takes two batteries, just some regular off-the-shelf camera batteries. So flip in here and here. So I've got to install this little wireless adapter right here. This guy's powering up. Get this scanner going too. This is a scanner, the other part. Tracker goes up on this tripod. A super lightweight little carbon fiber tripod. Get the legs extended on this. Get it set up over here. Got the tracker here. This is going to sit up in this tripod mount and then get tightened into place. I'll leave that here pointed at where I'm going to be scanning, which is going to be the side of the table once I've got this case put away. So see, there's the tracker and the scanner. That's everything we need from the case. So I'll put this away. Bring this part back over here. Get this aimed a little bit better for me. Got a little ball joint on there. You can aim this. You got a little like yaw joint too. That should be perfect. So the way this guy works is as long as these two cameras on the tracker can see some of the targets on this orb, the scanner itself, it knows where the scanner is in space in the coordinate system of that tracker, and it's able to collect data. So you've got two smaller cameras and some laser emitters on this device. Those laser emitters will project a laser grid onto the surface. Depending on how those lasers bend into form, it's going to pick that data up with these cameras and make really accurate 3D measurements of whatever's in front of this and place it accurately in this volume because of the tracker watching the scanner. Tell TViewer I'm going to start scanning. Pick up my scanner, click and release the trigger. And I've got lasers and I've got scan data going over to TViewer. I've got some scanning settings that I can mess with. There's some buttons on the back of the scanner I can use to zoom in and out, adjust some of my scanning settings while I'm going, exposure and such. I'm in my default scanning mode of laser crosses. So this is just your most efficient mode for scanning. Get your largest area the quickest. I've also got, if I double tap my trigger, got parallel lasers. So this is a little smaller field of view, but better at capturing higher resolution data. It lets you get a little bit closer to the part and really take advantage of the resolution of the scanner's cameras. I've also got single laser, so this is really good at getting inside of like nooks and crannies, inside of holes, and things like that. But most of the time you'll spend your time in laser crosses mode and then fill in any gaps later with those other two where you need them. Just making sure I get everything I can from this scanning position, and then we'll flip this guy over, scan it from another, and then combine those two together. That's everything I need here. So I can pause, scan all over the table there. We'll clean this up a little bit. We'll do a disconnected components, get rid of anything not attached to that main object we were scanning, and chop off the table. And there's our scan. We'll do a new scan, same settings, flip this part over, ready to go. Click start scanning, same thing here, just want to fill in everything. Mainly the stuff that I missed on the last scan because it was hidden. And then enough geometry in common with the first scan to use for alignment. So in that case, this inside portion is going to be what we missed last time, and then this outside portion is going to be what we're going to use for alignment. Notice anytime it pauses is usually because the tracker loses sight of the scanner for a moment. It just pauses so it doesn't collect any bad data, and then it'll just pick back up as soon as you've got visibility on that scanner again. Just want to pass inside here to make sure I've got anything I needed. I think I'm about finished here. There's that scan. We'll do the same thing here we did before. Do a disconnected components. And then a table delete. Rid of this chunk of the table too. Cool. So these two are ready to combine. I'm just going to tell it, tell TViewer which two I want to combine. Go into that combine dialog. And here I just need to match up common points on the two. I just want to spin these around until they're oriented roughly the same. You don't have to do that, I just like to do that. And then zoom in and pick common points. So like the serial numbers 2, there's a dot, there's a point on the end of that 2. We'll place the same point here. So let's do the center of this rib, and then the top of this rib. So notice this is how these two are currently aligned before I place that last point. And then once I place that, these two snap together and they're roughly aligned. If I click apply, the computer takes over and does a fine alignment, basically wiggling around one of those scans until it minimizes the error between the two. Once we've got that point cloud combined together, we're going to hit wrap, which is going to create a mesh. We zoom in really close, you see these individual squares, individual points represented as squares. Wrap is going to connect the dots between those points and make this into a polygonal model. So a full surface instead of discrete points, commonly saved off as an STL file if you're familiar with those with 3D printing, same kind of thing. And that's usually what we're outputting to go to reverse engineering software or inspection software or something like that. So here's our finished mesh. There we go, that's ready to go into whatever your downstream application is. If you're interested in learning more about the Nimble Track or anything else we do here at Digitize Designs, 3D scanning or otherwise,